The next area of chemistry which must be covered and is not the most popular amongst students is the mathematical aspects of it. And measurement is the first of these. The key to linear measurement is in centimeters. And reality is that centimeters are easily understood if you understand that 2.54 centimeters equals 1 inch. Since we are a country that deals in inches and feet and yards and miles, the inch as 2.5 centimeters is a pretty good rule of thumb if you're hypothesizing for any particular reason. The key to liquid measurement is a bit more difficult, primarily because when you measure a liquid in the English system or in any system, you have to take in the surface tension of the liquid again. And all of you noticed, possibly if you've ever poured water in a column, that there is a dip in the center. Now this is surface tension again. This is polarity reapplied. But you have to have a very accurately graduated column in order to measure properly. And the difference is the way you measure most of the time. For instance, if you start out with 95 milliliters and it drops down to 45 milliliters, you measure the difference between the 95 and 45 is 50 milliliters of liquid dispersed. This sort of thing allows you to adjust for that little dip, the meniscus, as we call it. Again, so polarity of water is just phenomenal. I hope you try a few drops on the glass plate. Or even go nuts and try the paper clip in a bowl of water. You got to be really still, and you got to have pretty steady nerves. At my age, it's pretty much not going to happen. So here's some interesting things. Some of the equivalents that you've never heard of. In cooking, 1 dash is 6 drops. 3 teaspoons is a half an ounce. A bartender orders a pony. That's 1 ounce. A jigger is 1.5 ounces. An equivalent measurement, 30 milliliters is 1 fluid ounce. So if you need an ounce of something, that's 30 milliliters. That might be something worth memorizing, just like the 2.5 centimeters per inch. So just a thought. A teaspoon is 5 milliliters for all you cooks. A cup is 0.236 liters, about a quarter of a liter. So if that's something you deal with a lot, it might behoove you to memorize it, that a cup is about a quarter of a liter. The equivalence of a quart is 0.943 liters, for those of you that want to get with it totally. A gallon is about 3 3/4, 3.785, I think it is, liters. So 3 3/4 liters per gallon. Sometimes that comes up. 2.2 pounds is a kilogram. Now, you do a lot of kilo equivalences in life in this day and age. The so-called metric system or international standard system, British system, whatever you want, isn't really the British system. The British system is the inch and the pound. The international system was put together by a bunch of scientists who wanted uniformity. you can understand that a pony and a jigger and a pound and a quart and a gallon are such disparate quantities, it would be very difficult to get any kind of reasonable equivalency. Thus, they went to the international metric system, which deals in centimeters and milliliters and that sort of. Okay, chemistry thus is milliliters, liters, grams, and kilograms, centimeters, meters, and kilometers. These are all easily expressed as basic units, and they're easily divisible because they're powers of 10. Obviously, if you needed in lab 30 milliliters of solution, and you ask your lab partner for a pony, it wouldn't work real well. Now, it'd be fun to mess his mind up or her mind up, but, don't do it too often. You won't actually be revered as a useful lab partner.